Hello everyone. In this video, we are going to write a simple Dockerfile for an example Spring Boot application. Here we will write the basic commands inside a Dockerfile. In the later videos, when we discuss about the best practices of writing a Dockerfile, we will improve the same Dockerfile for production-based deployments. So let us start. Before writing the Dockerfile, we need an example Spring Boot application. For that, let us generate the Spring Boot application. For this, we need to go to this start.spring.io website. Here there is a Spring initializer. Using this, we can generate an example Spring Boot project. Here we can choose the build tool Maven or Gradle based on Groovy or Gradle based on Kotlin. Here I am choosing Maven as the build tool. For language, I am choosing Java. This is the version of the Spring Boot. So this is the latest stable version. I am choosing this version. So for Maven, we need to enter the group ID, artifact ID and the packaging type. I am choosing the default ones. For group ID com.example, for artifact demo and name is demo. This is the description. And this is the package name. For packaging, we can choose either a jar or a WAR file. If we choose jar, it will generate a fat jar that will contain the web server as well. For example, Tomcat. So that means when we run the jar file, it will be deployed within the embedded Tomcat. We can also choose Jetty instead of Tomcat by changing the pom.xml. If we choose WAR, it will generate a WAR file that can be deployed in the Tomcat server, which is running in any of the virtual machines. Here we can choose the Java version as well. Once these options are selected, we can click on explore or create here. Let us explore this. Here we can see it is generating various files for us. For example, the pom.xml. So this pom.xml contains the group ID, artifact ID, and this is the snapshot version. So it includes the basic dependencies of Spring Boot like Spring Boot Starter and Spring Boot Starter Test. And also it includes the Spring Boot Maven plugin. So under source, we can see the demo application Java file. It also generated corresponding test Java as well. So now let us download this and we'll change this file. This is the zip file which I have downloaded now. I have unzipped it. Now let us modify the Java file. So this demo application is a RESTful web service. Let us import the corresponding packages and let us add REST controller annotation here. Now let us add a method here. Here let us return some value. So for this we need to add an annotation. So let us map this to request mapping. Here let us choose slash. This means whenever we access this web service by giving slash, then it will return sample application. So let us save this. So this is the sample demo application. Now let us try to build the application. So before building, I'll save it in a GitHub repository and I will download in the Linux environment. Now I have placed all the source code to the GitHub repository. So this repository I will use in my Linux environment. This is a Linux virtual machine. Here we will make the Docker image. Here I have already installed Docker. We can verify that. So it is working. Before writing a Docker file, we need to prepare the package of the demo Spring Boot application. So for that we'll use Maven. Here I have already installed Java and Maven. We can verify the versions. This is JDK 17. Here Maven version is 3.8.8. Now let us download the Spring Boot application from GitHub repository. So the application is downloaded. Now let us build and package the application. Here while compiling it has given some issue. So let me correct the application. So here semicolon missing. Let us save this file and build it again. The file is saved. Let me rebuild the application. So now it is saying the package is missing. So this is related to our pom.xml. We are missing some dependency there. Let me open the pom.xml. So here instead of Spring Boot Starter, it is Spring Boot Starter Web. So let us save this file. So actually this problem occurred because we have not selected the correct dependency when we are generating the application. So when generating the application code, here we need to select proper dependency. So for this example, we had to select the Spring Web, then it would have added the correct dependency. But anyway, we have changed it now. So let us build the application. So this time we did not get any issue and our build is successful. Now we can see the generated jar file. So this is the jar file which we have generated now. So before writing the Docker file, let us verify whether this jar is working fine or not by executing this jar file using Java command. So when we execute this command, it will create an instance of the Tomcat which is embedded inside the Spring Boot application, and it will run the application inside the Tomcat. So let us see that. Here we can see that the Tomcat is started on port 8080 and it has started the demo application. Now I can verify the application in another command window. So here let us try to access the application. So here we can see it has printed the sample application. So now we have verified the packaging of the application, which has created a jar file, and we have executed the jar file to see whether the application is running or not. So let me stop the application now. So let me correct the files here as well. So before placing these files in GitHub repository, let us also add the Dockerfile. So let me create a new file. I am saving this as Dockerfile in parallel to the pom.xml. So let me save this file. So here, before writing the Dockerfile instructions, we need to understand that the final goal is to run a Java application, which is a jar file. So for that, we need to have JRE inside the Docker image. So we need to use a base image which contains Java runtime environment. Here the from instruction tells us which base image will be used for this Dockerfile. For this I am using Amazon Cornetto JDK. So this image has already installed JDK inside it with version JDK 17. So let us add the maintainer here. So we can give any name here. I am giving test user. Before executing the jar file which we prepared earlier through Maven, we need to copy the generated jar file inside Docker image. So for that, let us use copy command. So here we need to mention the name of the jar file. So this generated jar file should be copied to one of the directories inside the Docker image. If you don't specify any directory, then it will be copied to the root directory. So for this demo, we can use the root directory as well. Here we can rename this file as per our requirement. In this demo, I am keeping the same name. So once this file is copied, then we can execute the jar file. For execution of scripts or any files, we can use either CMD or entry point inside Dockerfile. So let us use entry point here. So first we need to specify Java, and then we can specify the jar, and finally we need to specify the jar file. So here we need to mention the directory of that file. Since we have not specified any directory here, that will be present in the root directory inside the Docker image. So these are sufficient for this demo application. We can improve this Docker file when we discuss about Dockerfile best practices in the coming videos. So let us upload these files to GitHub repository. So now we have pushed the Docker file and other file changes as well into the GitHub repository. So let us refresh it. So here we can see our Docker file. Now let us build the Docker image using this Docker file, and let us try to create a container using the same image. So here let us pull the changes. Here we have got all our changes. So let us build a new Docker image for this demo application. So here it has downloaded this Alpine JDK image. So in this instruction we can see the copying of the jar file to a particular directory inside the Docker image. So now we can verify the Docker image. Here we can see a new Docker image with tag 1.0 is created. So now let us create a new container using this Docker image. Since the Java application runs on port 8080 inside the container, we will expose it to outside as well. So for that I will use -p. We can name the container my demo, and here we need to specify the name of the image, and we can run this container in a daemon mode. So now a new container is created. We can verify the container process. Here we can see that a new container is created with name my demo, and it is running on port 8080 within the container, and we have exposed to 8080 outside as well. Let us check the logs now. So this is the same log which we have seen earlier when we were running the Java command manually. So the same log is created by the container as well. So our container creation is successful. So let us verify using curl command as well. Here we can see the sample application is printed. So that means our Docker image creation and the Docker container creation are successful. So in this video, we have seen how to create a sample Spring Boot application, and we have used Maven as the build tool. And also we have seen how to write a simple Docker file to create the Docker image for the application. And also we have seen how to build that Docker image and create a container out of it. And we have tested the container as well. I hope this video helps. Thanks a lot for watching.